Welcome, and thank you for joining us today for the panel on how to use IIoT to grow the energy storage system. We look forward to the conversation. I'd like to point out a few housekeeping things. Please familiarize yourself with the webinar tool. Take a look around for the chat and the Q&A function tools. Also, please feel free to participate in the discussions. Post all your questions in the Q&A tool, not in the chat, as it will make it easier to answer them that way. Now, the track will run for about 55 minutes for the entire panel, and we'll leave about 10 minutes for the questions from the audience. So we really look forward to an engaging panel. We'd also like to thank all our sponsors for this conference, in particular IIoT World that is sponsoring this panel. For those who are not familiar with IIoT World focuses on delivering daily insights on the industrial Internet of Things across multiple verticals. Online, IIoT World curates a series of virtual events that draw thousands of delegates. Now, with the housekeeping out of the way, I'd like to introduce the topic and our speakers. The topic is how to use IIoT to grow the energy storage system. My name is John Yangon, and I'm your moderator for this panel. I'm a senior power and utilities consultant at SAS Institute based in Cary, North Carolina, where I advise energy and utility companies on how to leverage advanced technologies like artificial intelligence, machine learning, IoT, predictive analytics, to generate insights that can help to address electrification, decarbonization, and digital transformation challenges in the power and utilities industry. We have three panelists joining us today for this session: Dr. Sherif Abdelrazek, Alison Weiss, and Dr. Stefan Gervais, who I will introduce briefly, and then dive into the discussion. For their full bios, please be sure to check out the agenda page on the IIoT World Energy website. So Dr. Sherif Abdelrazek leads the Duke Energy engineering team that is responsible for design and integration of utility scale as well as commercial industrial energy storage, issues to do with microgrid and storage plus solar storage. He received his BS degree in electrical power engineering from Ain Shams University, and his MS and PhD degrees in electrical power engineering from the University of North Carolina in Charlotte. He holds 3 grid-tiered energy storage related patents and has authored multiple IEEE journals as well as conference publications. Next is Alison Weiss. Alison is an innovation infrastructure futurist, strategist, technologist, as well as communications expert. She advises entrepreneurs, investors, governments, regarding clean technology business with over 2 decades of knowledge built up in the renewables, clean technology, as well as finance fields. She was a senior strategist at the National Renewable Energy Lab, working on financing models for distributed as well as industrial solar, among other topics. She's a frequent speaker, presenting at key industry conferences in energy and utilities globally. Next is Dr. Stefan Gervais. Stefan has more than 30 years of experience in the high-tech industry, as well as global marketing, business development, innovation, project management, and product design. He has worked for multinational companies in Europe as well as in Asia on the consumer and industrial segments. Currently, Stefan is an executive vice president for strategic innovation and partnership, as well as smart data at Lacroix Group based in Paris, France. Welcome to all my panelists. Now, to kick us off, I'd like to give each of the panelists to offer brief opening remarks, explaining how their companies are leveraging industrial IoT to drive energy storage services, and why energy storage is important, especially for renewable energy integration and a deeply decarbonized electricity systems. Let's start with you, Sherif. Welcome.
Thank you, Joseph, and I appreciate the intro. So for Duke Energy, we're leveraged, or at least one area where we're leveraging IIoT is the energy storage systems we get on the grid. There's, as you all may know, there's a lot of unknowns in terms of lithium systems there, and specifically their degradation. So a big piece of an area that we're just, as an industry, not very familiar with is how different dispatch options affect the degradation of lithium cells, which are, as you may all know, not very inexpensive. So gathering in our operational projects, gathering real-time information, being able to analyze it on the fly and use that information to make decisions in terms of how we're going to dispatch these systems and how their life will be affected with such actions has been at the top of our list in terms of things we kind of want to get accomplished on our projects. So it's definitely an exciting time as we get kind of more and more megawatts on the grid and leverage these IoT technologies to facilitate it.
Great, thank you, Sheriff. Next, we have Alison.
Thank you. So, I'm approaching this conversation slightly differently than my two esteemed panelists, and I really look forward to learning more from them as we talk this hour. My role in this landscape is as a strategist, and I've been one in this arena for about 25 years. Looking at the equation from a systemic perspective. So when I hear energy storage systems, I focus on the system part of it. And that goes back anywhere from 2007, 2008, 2009, when I was with the National Laboratory System, and we were looking at something we called digital energy at the time. And that basically was IoT for the energy sector. It's had lots of names in the last 15 years. Now we're talking about industrial IoT. We're talking about that particular equation as part of the larger system. But for me, I'm looking at this from a technology agnostic perspective, both from storage technologies, and I think that Sharif is going to talk to that a little bit more with regards to the different ways in which we can create risk models that are based on technologies that are a little bit more astute with regards to some of the criteria of the system. I look at it from in terms of things that are equating to the best value proposition for IoT and for energy system as being a very important node in the larger smart grid arena, whether that's a smart factory, a smart industry sector, as part of a smart city, which is even part of a smart state. We're looking at the confluence between these technologies and the context, so policy and finance as well, to create really what the value proposition is. And so what I'm going to be speaking to today is kind of looking at the contextualization between how you make a decision as an industry participant and the best form of technology and how that relates to the larger system itself. Because where we accelerate our adoption of the smart systems, we accelerate the market penetration and the market possibilities for the sector as a whole. So as an aside, my relevance in terms of energy storage specifically, I am technology agnostic with regards to my background in the clean energy sector. But here I've done some deep dive projects with folks like Samsung looking at residential energy storage and how that created a possibility for what are now termed as virtual power plants. That of course has customers that are transforming between a consumer to a prosumer. We talk about that for the kind of the individual household level, but that also applies to commercial and industrial participants. That also applies to utility scale participants. So looking at that shift, and looking at the shift in the intelligence and systems overall, and the best choices for energy storage really focus on the systems part of the energy storage system and how that relates to the larger system.
Thank you, Alison. And Stefan, go ahead.
Yeah, hi everyone. I'm really glad to be with you today. And on my side, I'm a different perspective, right? As you can see on the slide, I'm coming from a mid-cap company, about 5,000 people all across the world, but we are doing a lot of design and manufacturing of electronic products for subcontracting, but also a lot of IoT products for smart city, especially for what we do in mobility, infrastructure, or what we have also in the water industry. What we do have a lot of control and of these water networks for more efficient water networks as well. We do this also for street lighting and having a V2X connectivity with different vehicles. However, I'm not here to talk about all of that. I'm more here to talk about what we do more on the smart grid side. And if you look at the next slide, this is something we are having in a different product, and one product line, which is really done in one of our company in that we bought over 3 years ago in Germany. We are number one in Germany in kind of substation automatization for smart grids. And even though I add a bit more than what we do, this is this kind of a data acquisition on one part, which is very important, with some kind of automatization at the local area. And of course, the possibility to communicate part of this data for better automatization and better control in order to have some remote data management and some kind of data analytics. So this is what we do for water and smart grid, and what we also provide is the design and manufacturing and part of a solution for all these, we say, customer utilities, mainly utilities, but also for some cities and for some region, counties as well, that they want to ever automatize their and better control their water network, but especially their smart grids and substation automatization as well. So on my side, I'm bringing what we do on this smart grid part, but also what we can do and what we do in all type of IoT in terms of innovation, in terms of breakthrough technologies, and in terms of use cases that are the outcome of this, we say, convergence between new technologies and new needs that we have in the smart cities, but also what we see from the utilities perspective and what is possible now.
Thank you, Stefan, and thank you to the other two panelists. So the first question, just for level setting, is what are the main issues to consider when examining new energy storage system technologies? Alison, do you want to go first?
I will. I think because I look at this really more from a bird's eye perspective. I realize that can be somewhat challenging when we're talking about the logistics and the boots on the ground case studies that Stefan and I'm sure Sharif are well aware of. But from my perspective, again, I'm focusing on the system of the energy storage system and how important that is with regards to true acceleration of this marketplace, and frankly, as this landscape fits into the larger infrastructure build out that we're going to see both near, mid, and long term. So when I'm talking about ESS, it's a critical node in kind of the rollout of both smart factories as a part of smart industry, which are a part of smart cities, which are a part of a smart state overall. When we talk about the grid, you know, we kind of tend to assume that we're talking about, in the case of the United States, for example, the national scale grid, right? Or if we're talking about it, the grid, we're talking about this macro entity. But I think it's really critical to start questioning what we mean by our definitions. So when we talk about the grid, are we talking about the global grid? Are we talking about our national grid? And for us, that would be here in the United States. Are we talking about a local grid that would be at a municipal level? And then within the definition of those grids, are we talking about a utility scale grid and what that utility scale means, right? Because now we have a landscape where we have microgrids, and are we talking about grids that are, quote, dumb versus grids that are intelligent? And what do we mean by that? And so for me, it's still going from a consumer perspective where folks in the commercial and industrial sector are consumers as of now, but as they enter into a landscape of a web of intelligent devices and applications that are bound together in a communication system that's leveraging the best of our physical assets for our intelligence assets, this starts to morph very at an accelerated rate. And so when you're looking at what you as an entity, as a business entity are choosing for your operations, you yourself, in order to accelerate and adapt in the way that I think that we see coming down the pipe, you as a business owner are transforming yourself from a consumer of just what is available in the landscape and what you just consume to a prosumer where you understand the intelligence and the data that is part of your system and the meaning of that for the larger grid. And so for me, it's very important to look at, when you're looking at just the technologies, well, what is the system in which that technology is performing? What are the operational realities? What are the real-time operational analytics that are available? How can you communicate in your local and your larger cloud infrastructure? All of those are questions that are now part of just the question of what the storage itself entails, because its value from the larger perspective is how it engages with the system as a whole. So we can all agree that the future of infrastructure is going to destroy the silos that we have in place now. It's going to integrate intelligence with the generation and distribution of clean energy. And it's the distribution of value, which is not only electrons provided, but it's also how we provide energy within the system. And frankly, the best value is how we don't deliver electrons. Where can we create efficiencies? Those efficiencies come from understanding the data. So it's critical that the data and all of this is taken into account when you look at the synapse between commercial and industrial users of storage, of energy used, but also potentially generated on a distributed fashion, and how that engages with the current local utility. But more interesting to me, the utility of the future, which might be entirely different from what we understand now. So for me, looking at energy storage, if you're really going to look at this as being a prosumer instead of a consumer, you have to look at how your factory, your manufacturing enterprise, your business entity fits in right now and could fit in the future to that larger intelligent grid, whether it's on a local level for you at a microgrid level or whether it's on a macro level. So I can talk for a lot longer, but I think the 3 C's is what I'll leave you with. We need to collect information that we are able to establish with the future technologies and the present available technologies with regards to storage. We need to communicate that information from the storage itself. Because from my mind, the storage is not only can be co-located with your operations, but it's part of that larger system. And then we need to be able to crunch the numbers themselves. This data has to be meaningful. The storage that you're creating, that you're communicating to the larger system needs to have meaning, and we need to be able to analyze that. So yeah. I'll shut up now. I apologize.
Yeah, that's a very, that's a very insightful, analysis of the complexity of the grid, and you're right on in terms of the different challenges and what needs to be done. Sheriff, do you have something to add to that?
Sure. So when you look at kind of different energy storage technologies, you should always start from the use case or the application level. That should be the first thing you look at, because I mean, if you look at the different storage technologies out there and you just look at I'll call it the parameter scorecard. In other words, things like round trip efficiency, double discharge, self-discharge, C-rate characteristics, it really doesn't matter that much unless you're putting it in perspective of a specific application. So just as a high level example, like a technology like lead acid batteries, seems to be pretty outdated at this point. And if you look at our grid, we're definitely not using that technology a lot on our grid tied systems at utility scale. But one of the reasons for that is just it's terrible round trip efficiency compared to lithium systems. But if you look at UPS systems, uninterrupted power supply systems, you will find that a lot of UPS systems leverage lead acid batteries. And the reason for that is because something lead acid batteries is really, really good at is storing energy and keeping it. Something it's not good at is round trip efficiency. But in a UPS, you're not cycling that battery that much. So really a poor round trip efficiency doesn't really matter that much to you. So in that case, in that scenario, a UPS, lead acid turns out to be the better solution. So that's accordingly, I think whenever you look at that, what is this technology suitable, or comparing different technologies, the first thing you should do is understand the application you have at hand first, and then find the most suitable technology for it. And there's no such question as what's the best energy storage technology out there.
Yes, insightful. Stefan?
Yeah, just let me add some. Of course, one of the answer is it depends. It depends of who you are and what you want to aim to do with such ESS as well. And mentioned by Sheriff, the use case is very important, and the use case and the benefits you want to have must outpace also the complexity to implement this one in a grid. It depends if it's a small grid or a smart grid or a bigger grid as well. It depends also who you are. We see some, especially in Europe, we see some users very sensitive about the sustainability of the solution, which is really implemented. How much sustainable is it? Is it something that is going to last 5 years, 10 years? How can you recycle all of that? And do you, what's the impact on the potential impact on the environment in case of a fire or any problem and everything? So this has to be considered, of course. And there is one more thing, but it's pretty obvious, but this is the total cost of ownership. This TCO, which is key for any new, I would say, things you implement on the grid. The TCO must be really carefully, I would say, calculated to make sure that what you implement at the beginning is sustainable along, we say, the many years. So you should use this kind of technology as well.
Oh, good. So energy storage systems really play a fundamental role in terms of mitigating uncertainties that originate from the intermittent power generation sources like solar and wind, thereby improving flexibility as well as reliability of the grid and power systems in general. Now, Alison, in your introduction, you discussed the drivers of innovations, in this space, the technical, the finance, as well as the policy drivers. Who are the key players in the energy storage space, and how do they engage, for instance, to support or deter industrial IoT solutions? And you can look at this from both private sector as well as the public sector.
Sure. So the main players, and it gets to be complex very quickly. So I'm just going to highlight kind of the main attributes, I guess, of each of the three kind of holy triumvirate of where we need to see leveraged participation and cooperation with the stakeholders in those sets to really accelerate an intelligent grid, whether it's on a micro level or a macro level. From a technology perspective, obviously, we're looking at the actual storage capabilities of different substrates themselves. So whether that's a flow battery, whether that's a lithium-ion battery, whether that's other new and innovative forms of technology for that energy storage capability itself and the efficacy of it with regards to its enabled interoperability with the larger grid. That is shifting and ever changing to some extent, but to other extents, it's very hard to introduce new technologies into the established systems, given the needs of both security for energy from the perspective of we need to make sure these electrons are available, to the long-term security of energy based on the decarbonization goals that we have. And so the tension for that is tantamount in the technology players. So you can have folks like Powerwall at Tesla that are doing a residential outlay where the real long-term goal is not to just have individual distribution and generation sources at the residential level. It's really to be able to create what's called a virtual power plant, where you have radically distributed generation nodes being able to be coordinated and participate in a larger grid for the needs of the larger system. So the technology players there are anyone from the residential level, from a commercial scale, from traditional types of substrates like lithium to the more innovative ones. Those need to be, again, I agree with Stefan and with Sharif, it's a case-by-case basis for you as a commercial participant. And yet what I would add to that is you also need to take into account that the strength of your actual generation capability for your own co-location needs, et cetera, still has to take into account your ability to interoperate with the larger cloud infrastructures to make meaning out of the data that you're able to now generate from your operations for that virtual system. So again, I bring up the question of when we talk about grid, what size and shape do we mean by grid? When we talk about distribution, what are the channels of distribution to whom and for what usage? Are we talking about a local community virtual power plant? Are we talking about a more traditional municipal infrastructure that's trying to be more intelligent but still isn't quite there yet? And the technology that's applicable in each of those cases is going to be varied. So the financial equation becomes really interesting when you look at how we are now looking at decentralized versions of financing itself, and what that means for having change agents at, for example, a smart city level, where you have a civic engagement that is been accelerated by people's ability to understand the data that they have now access to for example, energy, but other community level needs as well, like water, like waste management, like tax collection, like health services. I mean, it gets to be very complex very quickly. What we have right now are utilities that are used to being able to be just one silo. And in the energy utility infrastructure of the future, those silos are going to be decimated. And how we're going to get there is going to be very interesting. So looking at energy storage as a critical node in all of the smart infrastructure, having folks, when you're making a decision about your own entity, again, I go back to shift your thinking between being just a consumer of the electrons, a case study that is just unique to you at your location of enterprise, to, well, I'm a prosumer now, I'm a commercial interest, and yes, I have to protect my shareholder value, but now I have stakeholders that are larger just than my shareholder value, and how do I capture that to really accelerate my being part of a larger system as opposed to just having a microsystem? So from that perspective, when you look at the policy players here, they have an eye on that prize as well. And so the folks that are now engaged in the policy conversation have either already successfully put in smart grid infrastructure legislation on a state-by-state basis, and you want to look at states like California and like Illinois to look at some of the legislation that's in place there, but then also from a federal sector perspective. I mean, I think from us nationally, a lot of folks that may be on this webinar call today are very familiar with the bipartisan infrastructure legislation that has just passed, with trillions of dollars that are now available to localize municipal and state level action as it relates to transforming the infrastructure away from being simply a siloed space to one that's integrated, one that is intelligent, and one that actually can be more effective and efficient. But that policy and that funding that is a result of that policy has a couple of very significant barriers, in that we have all of these resources now financially that are available on a federal level due to this legislation, but we have a bottleneck between that availability and the understanding on a more localized level of what is actually needed there, what analysis is needed there to create the grant case, the loan case, for example. The loan program office at the Department of Energy has all of these resources. They need to get out to communities. The communities that need them have to have a conduit with which they can analyze what their needs are and apply for those funds. That's a little valley of death right now. In terms of that conversation. So how do we come up with innovative ways to create a breach between that, the financing that's necessarily not only from the federal and the national level here just in the United States, but more creative ways of financing things, property assessed clean energy legislation, PACE, crowdfunding sources for localized community renewable build out that is co-located with microgrid services that can give businesses, local businesses, manufacturing businesses, residences, and other users and producers of energy now at a distributed level, the intelligence they need to really maximize the data that they're generating in those systems. Which brings me kind of to the final point, is that, you know, all of these require better data management and better data availability and better data understanding. And we really need to have, from a local citizen perspective, from a political leadership perspective, from a utility decision maker perspective, from a utility corporate leadership perspective, a compact on how we're sharing that data, how we are securing it, how we are making it open and intelligible, and how we can have real-time optimization of the data that we collect from these systems, because that's where the bullet really will fire on full speed. And it's not just a silver bullet in this case, it's silver buckshot. So how do we organize and align that buckshot in a way that we're leveraging learnings so that we can really accelerate smart infrastructure quickly? Because the elephant in the room is that we don't really have much time when we look at the closing window with regards to decarbonization opportunity.
Absolutely. So certainly scale is a very important consideration, especially when assessing the how to encourage participation of different players, on the grid, because that will determine whether we go the microgrid route or we consider a much large scale system. And this is very critical for utilities as well. Sheriff, what do you think is most needed, especially for the growth of utility scale energy storage systems for large utilities like you, as for Duke Energy?
Yeah, great question. And just, some background to the audience about Duke Energy. We're the largest utility in the United States. We're survey 0.2 million customers and have more than 50 gigawatts of generation. We also operate generation, transmission, distribution, which means we have a very, very vast grid to deal with. And when you have a very awesome tool like energy storage systems or modern day energy storage systems like lithium systems that are, if you're not a power systems engineer, all you should know about grid tied battery systems is that they're extremely flexible, and in the eyes of a utility, it's almost like putting all types of generation assets into one very versatile and flexible tool. So, to answer the question, what do you think is most needed for the growth of utility scale energy storage? A lot of things, but if I try to prioritize and pick the highest one, it would be the development of industry standards and tools for the evaluation and comparison of different energy storage technologies. Because really parameters like, depth of discharge and round trip efficiency and just the usual suspects like self-discharge and others, characteristic to energy storage systems, alone can only get you so far to understand a certain technology. But if we have certain kind of standardized use case profiles that are specific to different use cases, and in that scenario have kind of scorecards that are specific to use cases, so you're not just saying this technology has these characteristics, but you're rather saying this technology has these characteristics for this application and these characteristics for that other application. So in that way, once we have these standardized, industry-wide use case profiles, we'd be asking the right question. As we're evaluating and growing our energy storage infrastructure, we'd be asking, all right, what is the best and most suitable technology for this application, rather than, like I alluded to earlier, what's the best energy storage technology out there? And there is kind of some progress in that direction. I see kind of a lot of new tools out there that are kind of allowing folks to evaluate different energy storage technologies easily and do an apples to apples comparison. One that I've recently kind of become aware of is it's called Storalytics Energy Storage. We've been leveraging it quite a bit recently, and there's many others coming in the pipeline. It's just a very exciting time for working on energy storage and evaluating these different and new technologies that are coming out day after day.
Right. So analytics is also going to be a very critical aspect to encouraging greater energy storage, and utilities are investing in this area, and also through partnership with other analytics companies, encouraging greater participation of different vendors in this area. Stefan, how can utilities use industrial IoT, particularly to grow hybrid energy storage technologies? Alison talked about co-location of different resources on the grid, like you're talking about energy storage and then renewable energy generation technologies. How can utilities use these IIoT to grow, particularly hybrid energy technologies, considering the growing renewable energy market?
Yeah, this is a big question, right? I'm just going to give some hints about what IIoT can help on this one. Knowing that we do a lot of things already on the smart grid side, but also I want to use some best practice which is done in IIoT for other type of markets and application, and that can be reused for this specific topic about the ESS technologies. What we see today is this IIoT part start to be really important when you want to simplify make it really simple to use and to manage when you start to have more and more assets as I would say bigger and bigger smart grids. If we talk about microgrids, everybody can manage more or less one microgrids, but if you start to scale up grids, you need to have way more information and to digitalize even more your smart grid network in order to make better decision. And why? Because adding the ESS technology is we have a lot of advantages, of course, and we're talking about this one. But this also imply way more complexity to manage for smart grids and for utilities. And balancing the network, for instance, this can help, but this can also unbalance the network as well. You need also, so IIoT can help, of course, to do that in a more automatized way, but also to feed all the information in order to take the right decision for balancing your network. What we see also is not only bringing all the necessary information to digitalize the smart grid and to be able to take a better decision through data analytics, but it's also to simplify the implementation of ESS technologies and this management through more automatization. For instance, what we call this technical control connectivity. You can add all the rules of these the different connectivities between different sources of energy through ESS directly into this IoT. It's through a simple algorithm, which is already done, and you just need to add some different parameters. So this can definitely help for scaling up this technology. And if you spread this ESS a bit everywhere, then it will be way more easy to ever change through some simple parameters the way you manage this each of them or all of them. Depends the way you want to do. What we see also some big advantage in kind of fault management and to make sure that there is a full monitoring of these ESS technologies, because we all know that, for instance, some batteries can have some problem, right? So monitoring temperature, monitoring the charge, the number of charge and everything. So making sure that you have the best quality of service and you can do all what we call the, I would say, predictive maintenance in order to make sure that you don't have any real problem on your smart grid because of this ESS technologies as well. And you can even go further by adding, we say, to optimize the way you service all these kind of ESS technologies, right? Since you know what are the problem, potential problem, and you can schedule your maintenance in a pretty smart way. And I would say one last thing I want to add, or two last things I want to add. The next one is to make sure so you optimize fully all the batteries you are having in terms of charge, right? And to do so, you need to fully digitalize this type of measurement of the battery and number of charge, the temperature, and how much you are using these batteries, so you can go, I would say, you can add years in terms of using batteries just by having the right measurement and the right local management. And the last thing is to make sure that you have intelligent smart decision, and the smart decision must be distributed through this IoT, and this IoT needs to have some kind of, local management and give you only the necessary information you need in terms of decision, so you can make an easy decision about how to manage it or not, this type of ESS technology. So I see a lot of advantage, of course. However, what we need to make sure that we all together design the right IIoT for addressing the right challenge and opportunities of ESS technologies implemented into smart grids.
Great. We have a few questions, from the audience. Please keep your questions coming. We'll try and cover as many as we can. So this is one of the questions from, he's anonymous. What are the biggest cybersecurity threats for the IIoT future, and how can we better integrate cybersecurity into the design of these systems?
Maybe I can jump in, right? Especially for smart grids in general, right? Cybersecurity issue, you can see this, one of the biggest threats you have is ransomware. Okay, if you are addressing ransomware, meaning that someone is going to try to get into your network and to hack your network for you to pay a ransom, you are addressing most of the cyber threat. However, now on smart grids, you have something different on top of the ransomware, which is the direct attack from hackers from another country or from another group, which is there to make sure that you stop your smart grid one way or the other. So they don't care about the ransom. The way to prevent this one, or at least the issue there, is uphill battle, right? Meaning that you always have to upgrade the way you get your defense upcoming compared to these threats. And we have a couple, of course, of many ways to do that. But one thing is clear on IIoT: you need to make sure that you have kind of containers between each functionalities, meaning that whatever is happening in terms of normal communication or wrong communication or a different type of software or even the stop of running in terms of sensors or actuators, we always have a safe mode where we go back to a mode where everything must work in a very basic way. So it means that normally, if it's well designed, and this is the architecture for all IIoT system within a smart grid, right? Or utilities, it's not only the IoT alone. Then whatever is happening on all the chain, you will not be optimized, you will not be efficient. However, you will always work whatever is happening on your grid.
Okay.
If I could just speak really quickly, again, this is kind of from a macro perspective, but the very need for having data available for real-time optimization necessitates having a certain amount of openness to the infrastructure. And so from the kind of a high level perspective, the security issues and cybersecurity issues, you have a tension always between the amount of openness in the architecture you have, the ability for those sensors to gather that data in real time from disparate nodes in a more open framework, and then the crunching of the numbers themselves with regards to the security needs to protect those assets once you have them. And so on the one hand, you want to have enough openness to get those real-time nodes and the real-time data for real-time optimization to accelerate the effectiveness and efficacy of the systems as a whole. But then the challenge is to how do you protect what those digital assets are once you have them and you're manipulating them. So
yeah. And Sheriff, Nigel asked, how has the advent of both industrial solid-state energy storage and the resurgence of battery storage influenced the market in terms of wholesale acquisition? And if you could also address this along the lines of long-duration energy storage systems, which has gained a lot of push recently. What do you think is needed for non-lithium technologies to succeed?
Yeah, that's a loaded question. First, the first part. So nickel metal hydride and solid state batteries. On the utility scale, we haven't been seeing a lot of activity in the area of these specific technologies. Where we have seen some recent activities with some new companies out there has been nickel hydrogen batteries, flow batteries, zinc technology. So we've actually at Duke Energy implemented a zinc air battery at one of our sites in North Carolina. But additionally, it's kind of zinc-based batteries like EOS that a lot of people may be familiar with. And so we're seeing a lot of these new technologies. We're evaluating them, looking at them closely. In most cases, you don't learn about the full technology until you actually do a pilot and are able to evaluate the operation and maintenance requirements, which isn't very clear on the front end as you're just doing a desktop review. So I think we're starting to see kind of a lot of activity in that arena, and as we realize that the lithium standard is only and I like how the attendee or Nigel he said like lithium is the current standard, which it absolutely is. And if we look at, well, why is lithium the current standard? The reason for lithium being the standard is just because of EVs, right? If you talk to a Samsung, if you talk to a CATL, if you talk to a BYD, and you tell them, hey, what percentage of your cell manufacturing goes to EVs and what percentage goes to utility scale grid tied or any grid tied battery, it's probably going to be at least like 80% EVs, 20% or less grid tied. So we're only using lithium on the grid because it has been pushed extremely forward by EV. But as we grow on grid tied batteries, I think a lot of new technologies are going to get an opportunity to shine. A lot of ones that are not that good on the energy density side, which really doesn't matter that much for just grid tied stationary systems, as opposed to an application like an EV. And that's where EOS is at, that's where Enervenue is at. So we're working with both, and we're working with flow manufacturers to kind of see where on the grid they can create the most value for our customers.
Let me just sorry. No, just adding one thing on batteries, right? Just be careful, guys, on batteries. Lithium, of course, is a big success, right? Why? Because it took us so many years just to develop this technology. It took more than 10 years for that. And I imagine it's a very old technology. It never really took off for some reason and everything. But to develop a good battery technologies, it takes many years. And the only advantage I see, let me say, there is a light. There is a strong, I would say, now there is a strong investment in this one, even though we are really lagging in terms of investment in chemistry, right? It is in the world, right? Was not something very sexy to invest in R&D in chemistry. Now we are back. The big advantage I see is smart grid technologies doesn't have much constraint in terms of size and in terms of even efficiency. So I believe that the next, they say, innovation we will get in the new type of battery, one of the best application is smart grid so far.
Yeah.
That's great. Alison, do you have anything to add to that, Nigel's question?
No, I mean, that it was addressed by both of my fellow panelists very, very well. I mean, I think, again, I'm just harping on the systemic nature of any new innovation that you choose to create in your operations. Just have an eye towards being a prosumer versus consumer, and that applies to being a participant in the innovation landscape as well. You can do a cost benefit of, okay, this is this cutting edge technology, I'll be one of the first users. What are the risks of that? What are the rewards of that? And taking a close look at some of these more innovative technologies, not as being pie in the sky pipe dreams, but participating in their development by actually taking the risk and incorporating them as a first case user yourself.
Yeah, and Alison, you had talked about earlier, you talked about the virtual power plant market, and this being a great opportunity for both energy storage systems as well as industrial IoT. Now, what are the lowest hanging fruits, especially for change agents in this area? And I would also like you, while you're answering that, there's a question from Leslie, which has come related to that in terms of why are we not seeing more innovation, especially in tangible and real-time energy efficiency mitigation measures?
Right. Well, part of the reason why there seems to be, from my perspective, and this is just only one person's perspective, but with a pretty good purview of the situation, there, I again mentioned the valley of death in this instance between now available infrastructure resources from legislatively approved process, leveraging those now public sector funds with private sector funds that could potentially be in play with the appropriate projects. And there's that dearth of communication between appropriate local projects from a grid infrastructure perspective. So these would be multiple stakeholders kind of rolling out a virtual power plant system, which its definition is one if folks aren't familiar with. Basically, you have distributed generation assets that are able to be co-located with some sort of storage so that the larger utility within that service territory can access, in terms of flexibility, a supply of that flexibility from the grid when they have a demand for it, right? And that can be from a grid operator perspective or for an energy exchange perspective, but that's essentially what a virtual power plant is in a nutshell. And so you can see where the industrial participants that are part of an industrial IoT system with their own generation assets and storage assets could benefit from an established exchange, could benefit from supplying that flexibility to their appropriate grid operator. What the challenge is simply, not simply, complexly, these growing number of both public and private sector financial assets for those kinds of projects, and the ability of those localized, whether it's municipal, statewide, or other folks to understand and analyze what they actually need in their quote service territory. And so the challenge is to be innovative about how we are matchmakers from the availability of the resources to the need for the resources. And there's some really interesting kind of pilot projects going on in that space that have to do with best practices and learnings between established smart city infrastructure, quote unquote, because no one is entirely intelligent yet, but there are folks that are kind of further down the pipeline, with other folks like a sister city sort of program where you'd have folks that already have the smart infrastructure in place, kind of sharing best practices with folks that are trying to catch up and trying to get up to speed. So to answer the question, why aren't we seeing more? We're not seeing more right now because we are struggling with that disconnectivity between the assets available from the public and private sector and the need for them on a project level. But there are innovations in process to hopefully address that.
And
synapse that needs to be completed.
I'll just add, like Leslie's questions is really spot on. So the first part of the question, right? You're looking a lot like at energy storage, and you have losses while you're storing energy, you have losses while you're discharging that energy. Why not look at just kind of energy efficiency programs and just avoid these losses to begin with? And the answer there is both are needed. So if you look at our Duke Energy carbon plan, Carolina's carbon plan, which aims to reduce our carbon footprint by 70% compared to our 2005 levels by 2030 and reach net carbon neutrality by 2050, you'll see in all of the generation mix scenarios, and we have 4 generation mixes for that plan, in all of them, there is a category for energy efficiency programs to reduce just energy consumption without needing to store energy. So it's a very, very good question, a very good point to think about. And my answer there is that we are looking at that, and I'm sure other utilities around the nation are as well.
Yeah, and Stefan, go ahead.
No, let me add my 2 cents. We are paying also the legacies of our grid today, right? We are trying to adapt a technology which is not fit and not designed for storage of high voltage like we have in a smart grid. We're trying to adapt two technologies which are very different and not done and designed for that. So yeah, we try to adapt, and it's quite new to have this kind of we say storage energy as a big scale. My question also is maybe even to Sheriff and Alison is if we have to redesign all the grid today, I believe that we might have a grid based on DC voltage instead of AC voltage, with all what are happening now and with different type of voltage, and then we can talk about it being way more efficient to store the energy and so on and so forth. But I believe we are also paying the legacies so far.
Yeah, absolutely. And Stefan, still on you, considering the benefits of ESS technology, especially when reviewing the renewable grid, as the future, what are your 1 or 2 key takeaways, from this discussion?
I wanted to take away about sorry.
About the value of energy storage systems and the role they can play.
Oh yeah, of course. Yeah, absolutely. We have let's put one of the key takeaway. We have not really discussed too much, but we don't have much time as well. But about the big advantage and what we have, especially because we are operating a lot of things in Germany, with a really strong need in using renewable energy. And as you know, we have many types of renewable energy. So ESS technologies it's starting really to have a strong interest, even from Smart City, by the way. I just check and how they do this in a very sustainable way. So digitalization is key. It's even more important to have a well digitalized smart grid in order to make this we say technology adopted and easily we say manage, control, even automatize for the smart grids. I would say that's some of the key takeaway, but there is still there is still a lot of work to do. However, we believe that by cooperation and partnering on the full value chain, we should be able to address all these topics.
Sheriff, 1 or 2 key takeaways?
Just from a utilities perspective, there's just endless possibilities to what you can do with a grid-tied energy storage systems, either directly through renewables, as it's called, renewable smoothing or renewables firming, or on kind of just for the bulk system and ancillary services. So it's a very exciting time for energy storage, especially as we see all these new technologies come in.
Great. Alison?
Simply put, I see the future is very bright for energy storage systems having a systemic approach. I think that we have a great opportunity to look at resilience models that do have a bit of complexity and has a fair amount of give and take with regards to the stakeholders in those systems. But we're at a point now with regards to ICT, with regards to infrastructure as it exists, that we could transition to something that's much more malleable, efficient, effective, and potentially replicable. And I applaud folks like Sheriff at Duke and Stefan at LaCroix for doing the work that they're doing. And thank you so much for allowing me to pontificate today on my prosumer rant. So I appreciate it.
Yeah, thank you again to all the panelists for this amazing insights and knowledge. And thank you to our sponsors again. Your support ensures that we have all this great content to share. And thank you to our attendees for listening in and your great questions. Next, it's time to move into the next panel, readiness built on and trust against the surge of industrial cyber attacks. Have a great afternoon.
Bye-bye. Thanks very much.
Thank you.
Bye.